Assalamu alaikum dear students. Today we are going to study paper 2. We are going to solve the paper 2 theory, and this theory paper, and its code is 507021 is the variant, and May June 2015. Its provided time is 1 hour and 30 minutes. Okay, here we go. So we have the first question. Section A, it has the 45 marks. Okay, so choose the from the following organic compounds. We have been given organic compounds. To answer the question below, butane, butanoic acid, butyl ethanoate, ethanol, ethyl butanoate, methane, methanol, methyl propanoate, propane, okay, propanoic acid, and then propanol. So name the compounds that reacts with the magnesium to make the hydrogen. So we know that any kind of the carboxylic acid means any kind of the acid can react with the metal to form the salt with the hydrogen. So I am taking here butanoic acid. Okay, butanoic acid. Okay, don't need to write equation, but just you need to keep concept in your mind. Okay, acid reacts with the metal to form the salt and the hydrogen. So hydrogen is found when the magnesium reacts with the butanoic acid. This compound can be oxidized to make the propanoic acid. As we studied, due to oxidation of ethanol, ethanoic acid is formed. In the same way, due to oxidation of propanol, propanoic acid will be formed. So sorry, propanol is oxidized. Okay, next, name the two compounds that react together to make an ester. Okay, we have to make ester, so we need to take two compounds. We know that the compounds which are used for making ester, one is ethanol and other is the any kind of the carboxylic acid. So I can take here butanoic acid and ethanol, butanoic acid and ethanol. Okay, here we have which compound has the following structure. Its name is ethyl and this is butanoate. Okay, ethyl butanoate. This ethyl comes from ethanol, okay, or ethyl alcohol, and this butanoate comes from butanoic acid. So this is an ester. This is an ester. Name the compound which has a molecule with 11 atoms only. A molecule with 11 atoms only is propane. Okay, C3H2 more than double. Double is 6 and 2 more 8 because it is alkane. So alkane has general formula CnH2n plus 2. You understand it? Okay, 2 more than double. So 3 plus 8 it becomes 11. So I'm writing here propane. Okay, calcium. Some calcium compounds are used by farmers. Calcium hydroxide dissolves in water to form the lime water. Okay, when the carbon dioxide is bubbled through the lime water, we have the lime water. Okay, calcium hydroxide when it was dissolved in the water. So calcium hydroxide when dissolved in the water it becomes aqueous. Okay, so when carbon dioxide is bubbled through it, so a precipitate of calcium carbonate is found. Okay, this one calcium, this carbon dioxide takes one more oxygen from here, it becomes CaCO3. It is in solid form, that's why its precipitates are formed. Two hydrogen and one oxygen is left, so H2 is formed. This is liquid, this is aqueous, and this is the gas. Okay, so calcium dioxide is used to neutralize the acidic soils. It's basic, that's why it is used to neutralize the acidic soils. Okay, which is called liming. Explain using the ionic equation why calcium hydroxide can neutralize the acidic soil. So we know that calcium hydroxide being a base provides hydroxide ions which neutralize H plus of acids and water is formed. Like hydroxide ions, aqueous, react with the hydrogen from the acids, so H2O liquid will be formed. Okay, water will be formed. Okay, a farmer uses ammonium nitrate as the fertilizer. So here we have a farmer who uses the ammonium nitrate. You understand what is ammonium nitrate? NH4 and NO3 as fertilizer on the acidic soil. Okay, this is a fertilizer and the soil is acidic. So we have to remove the acidity. So he then uses the calcium hydroxide. Calcium hydroxide is used, okay, to neutralize the acidic soil. Explain, okay, this is the benefit that we can remove the acidity by using the calcium hydroxide, but it has one disadvantage. Okay, so that one disadvantage of the using calcium hydroxide to neutralize this acidic soil. Actually, what happens? This calcium hydroxide, okay, it reacts with the ammonium nitrate, and the ammonia is released. Okay, so we don't need to write equation, but just to explain, I'm writing here equation. Okay, that when we have ammonium salts and it is allowed to react with the any alkali, okay, so ammonia gas is released. So ammonium nitrate NH4 NO3, it reacts with the calcium hydroxide. You will not have to write this one. Okay, so calcium nitrate is found NO3 twice, so I will have to write here 2 because 2 NO3 I'm taking. Okay, 2 NH3 will be formed from 2 NH4, so one hydrogen from each NH4 is left, so 2 hydrogen and 2 hydroxide will form 2H2O. What we need to understand, I'm going to erase it because this is not part of your, okay, answer. You have to write that ammonia gas is released when ammonium nitrate reacts with the calcium hydroxide, and in this way nitrogen contents are decreased. Okay, calcium hydroxide will react or can react with the ammonium nitrate, okay, and ammonia gas will be released, resulting deficiency of nitrogen in the soil, or nitrogen deficiency in the soil, nitrogen deficiency in the soil. Okay, because you know that nitrogen is very important, it is used for making the proteins. Okay, so it's very important element which is provided through the fertilizers to the plants. When it is removed, so it means the main benefit of using fertilizer has been decreased. Okay, calcium, and then we have hydrogen, we have phosphorus, we have oxygen. Okay, 4 elements we have, and the percentages are given: 11.1 and 1.7, 26.5, 54.7. Okay, so here we divide by their atomic masses, so you can use the calculator over here. Yes, this is 0.4275. Okay, then it's as it is, 26.5 divided by 31, 0. Okay, what's the answer? 0.854. It is as it is 1.7. Okay, and 54.7 divided by 16, 3.41. So the least one can be divided on the all of these. Okay, so 0.4275. Okay, 0.4275, 0.4275, and 4275. This is one time. Okay, so 1.7 divided by 0.4275 is equal to 3.97. Almost it becomes 4. Okay, 0.854 divided by 0.4275, it becomes almost 2. Okay, and here we go for third. 3.41 divided by 3.41 divided by 0.4275, it becomes almost 7.97. We can simply write it like this. It becomes 8, it becomes 2, it becomes 4, and this is 1. Okay, so it means calcium is 1 time, hydrogen is 4 time, phosphorus is 2 time, and oxygen is 8 time. So empirical formula is this one. Okay, this is the same, it has the same empirical and the molecular formula, I think. So anion is actually, it would be like this, that H2PO4, because H3PO4 is the phosphate, and by removing one hydrogen it will become H3PO4 is phosphoric acid. When one hydrogen is removed, it becomes H2PO4 minus. Okay, plus hydrogen has been removed because it is acidic. So it is taken twice because calcium has +2 charge. Okay, so we have empirical formula CaH4P2O8. Okay, as it is. And anion has the formula H2PO4 minus. Okay, A3 ozone molecule is continually being broken down and formed in the upper atmosphere. The equation shows one way in which the ozone is formed in the upper atmosphere. You can say that atomic oxygen is being used with the molecule oxygen, and ozone is being formed. And here the minus shows that it is the exothermic reaction. Okay, so explain in terms of the bond breaking and bond forming why this reaction is exothermic. So you know that the amount of energy used in the bond breaking is lesser. Okay, the energy is absorbed. We have to write three things. Okay, energy is absorbed for bond breaking, and released for bond from bond formation. Hence energy absorbed in bond breaking is lesser than energy released during bond formation. Okay, so it is exothermic. Okay, when one mole of the oxygen molecule reacts with the reacts, so this amount of energy is used, is released. Okay, 392 kilojoule. So calculate the amount of the energy released when 48 gram of the oxygen molecule reacts. So this is a given mass, okay? Given mass is the 48 gram, okay? And the molecular mass of oxygen, you know that O2 is used, so it is 32 gram per mole. So here we use n number of moles, given mass over molar mass, okay? So here we have 48 over 32 gram and gram per mole. You know that gram is cancelled with the gram and per mole will become mole, and 1.5 moles, okay, is equal to number of moles. So we can take ratio method over here, number of moles and the energy, okay? So energy is 392 when 1 mole of the oxygen, okay, for 1 mole, and when we have 1.5 then x, so x is equal to 392 multiplied 1.5, okay, 392 multiplied by 1.5, so 588 kilojoule. Its kilojoule is written over here, so that's why 588. Name the pollutant that depletes the ozone in the upper layer. Chlorofluorocarbon. Chlorofluorocarbons. It releases free radical of the chlorine, which reacts with the millions of ozone molecules. Ozone molecule decomposes in the oxygen molecule into oxygen molecules. Okay, you can see over here what's written, that we have ozone molecule decomposing into the oxygen molecules in a reversible reaction. You can see over here this reaction 2O3. This is the 2 molecules of the ozone and 3 moles of the oxygen molecule. Oxygen molecule will be formed, and this is endothermic reaction, okay, because it's positive, so heat is provided. The reaction reaches an equilibrium if carried out in a closed container or closed system. The reaction is studied at the temperature of 400 centigrade. Describe and explain what happens to the position of the equilibrium if the pressure is increased. You know that when the pressure is increased, so gases from their higher mass to the lower mass, they will move, okay, in the equilibrium. In the case of equilibrium, when the pressure is increased, so gases from their higher masses, higher volume to the lower volume, they will shift, okay. So you can see over here that we have three moles of ozone molecule, of oxygen molecule, and 2 mole. So when the number of moles are higher, so it means the volume will also be high, so reverse reaction will be favored, okay, due to increase of pressure. Okay, what will happen to the position of gases? Shift from high volume to low, okay, um, during equilibrium. I have taught you this in the Lichtenstein principle, okay. So what will happen over here? So equilibrium will be shift towards the this is the right and this left, okay. Equilibrium will shift toward left side, favoring backward reaction or reverse reaction on increasing pressure. So what will happen? The reaction is studied at 25 atmospheric pressure. Okay, this is the pressure. Describe and explain what happens to the position of equilibrium if the temperature is decreased. Okay, you know that this section is studied at it's already been told that temperature of 400 centigrade. This is the temperature. Okay, so describe and explain what happens to the position of the equilibrium. Actually, this temperature, it is provided for the forward reaction. Okay, because this reaction, this dynamic equilibrium is achieved, is established at 400 centigrade. Okay, so basically this is an endothermic reaction because we need to provide the heat. Okay, you have seen over here, so we need to provide the heat over here to favor its forward reaction. So when describe and explain what happens to the position of equilibrium, what will happen to the position of the equilibrium if temperature is decreased. So when we decrease the temperature, so endothermic reaction, rate of endothermic reaction is decreased and rate of exothermic. If the forward is this shows the forward reaction. Okay, rate of forward reaction is, this is endo. Okay, but rate of reverse reaction will be exo. Okay, sorry, reverse reaction will be, forward reaction will be endo, then reverse will be exo. Okay, so in this way, on decreasing temperature, okay, exothermic reaction will be favored, will be favored. So dynamic equilibrium will shift to the left in backward direction. Okay, because it is the exothermic. Describe and explain what will happen to the rate of reaction if the temperature is decreased. Here, it's not being mentioned the dynamic equilibrium. So simply here we can take the collision theory. Okay, so describe and explain what will happen to the rate of reaction if the temperature is decreased. So in case of forward reaction, when the temperature is decreased, so kinetic energy is decreased. On decreasing the temperature, kinetic energy of the molecules also decreases. So when the, you can see that when the molecules have the lower kinetic energy, so their collision or effective collision or successful collision will be less, and the rate of reaction will also be decreased. Okay, so here we are writing, on decreasing temperature, kinetic energy of particles will decrease, resulting in less successful collisions, hence rate of reaction will be reduced. Two types of sulfur are, we have been given, these are two isotopes. Okay, so what is meant by the term isotope? Isotope, the atoms of same element, okay, with same atomic number but different atomic masses. Okay, number of neutrons, so complete the table for this is, okay, you can see these are two isotopes, they have the same atomic numbers 16 16, and atom mass is 32 and 33, these are different. So that's why we can say that same atomic numbers but different atomic masses. Okay, number of neutrons we can see over here for sulfur 16 and 33. So number of neutrons, we know that number of neutrons is equal to A minus Z, means A means atomic number. Okay, 33 minus 16, it becomes 17. Okay, 17. Number of protons, atomic number Z is equal to number of protons. Okay, so 16 is the number of protons. Electronic configuration, so we know that protons are equal to electrons. Okay, if we have the 16 protons, so 16 electrons will be there. Okay, so we can write 2, 8 and 6. Okay, 2, 8, 10 and 6 is becomes 16. Sulfur forms a simple molecule which has a relative molecular mass 256. Okay, so just the formula of sulfur molecule. Simple molecule is there, so we know that 256, and we know that the mass of one sulfur is atom is 32, so it becomes 8. So it means in that single molecule, okay, there are 8 atoms of sulfur. A sulfur molecule contains 8 atoms. A single simple molecule of sulfur contains its 8 atoms. Like this. Okay, if you only write S8, this will be the also good answer. Sulfur has low melting point and does not contain electricity. Why? Explain why sulfur has low melting point. Due to weak intermolecular forces. It is a simple molecule, simple covalent molecule. Okay, so sulfur is a simple covalent molecule. Okay, so due to weak van der Waals forces, or you can say intermolecular forces, it's you will have to write full. Okay, intermolecular forces, its melting point is low. Melting point is low. Explain why sulfur does not conduct electricity. Due to absence of mobile electrons. Mobile are free electrons, are delocalized electrons. Okay, sulfur reacts with the potassium to form the potassium sulfide. Okay, K2S, because you know that it has plus charge, K plus, and Ls has minus 2 charge. Okay, so 2 1 metal and non-metal K2S. Okay, this will be ionic. Write the formula and electronic configuration of the positive ion of the and the negative ion in the potassium sulfide. So positive ion formula is K plus, and we know that it has actually 19 electrons, but when it removes one electron, so it becomes plus. Okay, so electronic configuration is 2, 8 and 8. Okay, 18 it becomes, just like argon to become stable. Okay, so negative ions, it has the formula is S minus 2 electronic. It has actually 16 electrons, but when it gains 2 electrons, so it becomes minus 2. So now it has 18 electrons. Okay, 2, 8 and 8. Okay, sulfur reacts with the hydrogen to form the hydrogen sulfide. We have this hydrogen sulfide. Draw the dot and cross diagram to show the bonding in the molecule of the hydrogen sulfide. Only draw the outer shells. Okay, you know that sulfur belongs to actually, so we know that sulfur belongs to 6th. Okay, and it has 6 electrons in the outermost shell. 2, 8 and 6, 16. It has the atomic number, so atomic number is equal to electron number. Okay, and we can see that hydrogen belongs to first stage, so it has only one electron. So I'm going to draw their outer shells. Okay, sulfur is like this. You can see it has its electrons will be represented by the dot 4 1, which is going to be shared with the hydrogen. Okay, I'm going to make it bigger one. No, it's okay. Dot of sulfur and cross from the hydrogen. Okay, electron of hydrogen is represented by, and this is also cross. Okay, sulfur, hydrogen, and hydrogen. Hydrogen sulfide reacts with the sulfur dioxide to form the sulfur and water. Hydrogen sulfide. Hydrogen sulfide is H2S. Okay, so write equation for this reaction. H2S reacts with the sulfur dioxide SO2 to form sulfur and water. Sulfur and water. Water is formed H2O. Okay, so here we have two oxygen, so I will have to write 2 over here. So 2H2O. Two twos are 4, and here 2 oxygen, and this 1 sulfur and 2 sulfur from here. Okay, because 2 is multiplying with this as well, so 3 sulfur will be formed. Okay, so you can see over here we have A5. The flow chart shows some reaction of the copper nitrate, copper 2 nitrate. Okay, CuNO3 twice. So when the copper nitrate is strongly heated, strongly, so it will decompose to form the black solid, that is the copper oxide, and a brown gas, we don't know which gas that is, and a colorless gas that relights a glowing splint. From this clue we can understand that any gas which relights a glowing splint, it is oxygen. Okay, so which gas it is? Let me tell you, you have not studied the decomposition of any nitrate. Okay, so when we have copper nitrate, understand it, so and it is heated strongly, so it forms the metal oxide, that is copper oxide, nitrogen dioxide NO2, and oxygen gas O2. Now let's see, copper is 1, so copper is 1 oxide, we have taken 1 oxide over here. Okay, so nitrogen dioxide, there will be 2 nitrogen oxide. Okay, 2 twos are 4 and 1 5, and we have only 6, so I'm writing here 1 by 2 O2. Okay, so this brown gas will be definitely NO2, remember it. Okay, whenever we have metal nitrates and it is strongly heated, so it will decompose into the black solid, that is the metal oxide, and a brown gas, that is the nitrogen oxide, and a colorless gas which relights the glowing splint, which is the oxygen. Okay, so next is, this is solid and it can be, all nitrates are soluble, so it will become the aqueous when it is dissolved in the water. Okay, it will become the aqueous. So a reagent which will react with this to form the copper carbonate, and copper carbonate, as it's insoluble, and due to presence of copper, its color will be green, so green precipitates will be formed. Okay, and when it is warmed with the NaOH and aluminium, so a colorless gas is formed and light blue precipitate will be formed. So light blue because of the copper hydroxide CuOH twice. Okay, let's write here what the questions are. When 2 moles of copper nitrate are heated strongly, 2 moles of copper oxide and 1 mole of A. This thing A. Okay, 2 mole of copper oxide and 1 mole of A and 1 mole of B are formed. Or write the formula of B. B is oxygen. Okay. O2. Construct the equation for the action of the heat on the copper nitrate. When the 2 moles of copper nitrate, I'm writing here 2 moles. Okay, CuNO3 twice. So 2 mole of copper oxide, 1 mole of A, I'm writing here simply NO2, and 1 mole of oxygen will be formed. So let me tell you, sorry, 4 mole of A, 4 mole of A. Now let me tell you, I write it simplified form. Okay, I wrote here 1, so copper oxide is 1, and 2 times this one and half times this one. Okay, he wrote 2. Okay, so you can see 2 copper, and how and nitrate 2 2s are 4, so 4 nitrogen, 4 1s are 4. Oxygen, 2 3s are 6 and 6 2s are 12. 2 1s are 2 and 4 2s are 8. 8 plus 2, it becomes 10, and 2, this becomes 12. Okay. An aqueous copper nitrate is formed with the aqueous sodium hydroxide and aluminum powder. Name the gas C and D. Okay, let me write over here. We have copper nitrate. It is allowed to react with the sodium hydroxide NaOH. Okay. So copper hydroxide will be formed. Okay. No, not copper hydroxide. Actually, it will reduce to form. You know that ammonia gas is formed. Okay. You have studied the test for nitrate when sodium hydroxide is added and aluminum. So colorless gas is the of ammonia will be formed. Okay. And blue precipitate of copper hydroxide. What's the question over here? Name the C. C is ammonia. You know that when nitrate is heated with the sodium hydroxide and a piece of aluminum is added, then ammonia gas is released. You must know that. Okay. So this is the test for nitrate ions. And D is the copper hydroxide, which has the blue precipitates. Okay. It's insoluble. Suggest the name of the X and construct an equation with state symbol for the formation of green precipitate of copper carbonate. So what will be the X over here? X is definitely, I think, it is the hydrogen carbonate. Let me try it. Anything which has the carbonate. Okay. Let me tell you, suppose we have copper nitrate. Okay, and X reagent we are taking here hydrogen carbonate H2CO3. So what will be the reaction? Copper carbonate CO3 and 2HNO3 nitric acid. Okay, these 2H with 2NO3 nitric acid. Okay, which will be the aqueous, and this is solid. Okay, green precipitate of copper carbonate. So wait, what I have to write? Anything which is the aqueous. This is aqueous. This is also aqueous. But from here, 2H with 2H will be cancelled, and 2 nitrate with the 2 nitrate will be cancelled. Okay. So is it clear? Means when we write the ionic equation, so from the products it will convert into ions. This will not convert into ions. So 2H with the 2H of the this, because all of these will be converted into the ions. These are aqueous. Okay. So you will see that these are all aqueous. Okay, so these will convert into the ions. Okay, from the reactant sides. So 2H with the 2H and 2 nitrate with the 2 nitrate will be cancelled. Okay, and copper carbonate will be formed from the copper and the carbonate. Let me write full over here. Copper carbonate. Sorry. Copper nitrate NO3 twice plus hydrogen carbonate forms copper carbonate blue precipitate plus 2HNO3 aqueous. All these aqueous will convert into their ions. Cu plus 2 aqueous plus 2NO3 minus aqueous plus 2H plus aqueous plus CO3 minus 2 aqueous. From the product side, this will not convert into the ions, as it is 2H plus aqueous plus 2NO3 minus aqueous. So you can see over here that 2 hydrogen will be cancelled with the 2 hydrogen and 2 nitrate will be cancelled with the 2. So remember that from the product side, anything which is aqueous, so its ions will be converted. I can write directly over here. 2 hydrogen will be cancelled with the 2 hydrogen of this because it is going to be converted. Okay. When all the reactants from the are aqueous and they convert into their ions, so 2H with the 2H and 2 nitrate with the 2 nitrate, remaining will be the ionic equation. Okay, so we have gone through the all steps. You will see Cu plus 2 is aqueous. It will react with the CO3 minus 2 aqueous. It will form copper carbonate solid. Okay, name the reagent. I'm writing here H2CO3 ionic equation, Cu plus 2 and CO3 minus 2. These are aqueous in the aqueous solutions. Okay, and copper carbonate will be formed, which is a solid precipitate. Okay. Okay, here we have the section B and 3 questions from this sections you have to solve, and the marks for this section is 30. So an aqueous solution of the ammonium nitrate, ammonium nitrite, not nitrate, nitrite means NO3. Okay, so decomposes when heated gently. Okay, you can see over here NH4 NO2 when it is heated gently, so N2 plus 2H2 is formed. So describe how you could show that aqueous ammonium nitrite contains ammonium ions. Okay, so how can we show? What is test for ammonium ions? That it contains ammonium. In the aqueous, without heating it, if we add when calcium hydroxide and it is heated, so ammonia gas is released. A gas is released which converts the red litmus paper to blue. What happens in the aqueous solution of copper nitrate when we add any alkali? So a gas is released which converts the red litmus paper to the blue. Okay. Strong alkali is heated with NH4 NO2 aqueous. A gas is released which converts red litmus paper blue. Hence, ammonium ions NH4 plus are confirmed. Okay. From chapter 12, you have to understand it. Okay, sample. You have a sample 25 cm cube, and its concentration is 0.500 mole per dm cube. Okay, aqueous nitrite is heated. Calculate the volume of nitrogen formed. Okay, so we know we have been given the volume, that is 25 cm cube. So divide by 1000, it will become 0.025 dm cube, and concentration is equal to 0.500 mole per dm cube. So we know that number of moles is equal to concentration multiplied by volume. Okay, so concentration is equal to 0.500 mole per dm cube multiply volume is 0.025 dm cube with per dm cube will be cancelled. Okay, and you will see what's the answer over here. 0.500 multiply by 0.025. Am I right? Hopefully. Okay, so 0.0125. concentration of, this is the number of moles of the ammonium nitrate. Okay, we have to compare ammonium nitrate, NH4 NO, NO2 nitrite, ammonium nitrite, not nitrate, and N2. So I can see over here that what is the ratio between them. Ratio is 1:1. Okay, so 1:1, and if we have 0.0125 x, x will be equal to 0.0125. What we have to find? Volume multiplied by 24, because 1 mole contains 24, multiplied by 24, 0.3. This is the answer. Okay, how would you know that? Instead of doing this, you can also do third step. Okay, number of moles, ratio volume. 1 mole 24 dm cube, and 0.0125 moles x. Okay, x will be equal to 0.0125 multiplied by 24, 0.3 dm cube. Okay, so 1 mark for this, 1 mark for this ratio, second mark, and third mark for finding the volume. So you will get 3 marks. Okay, ammonium nitrate, this time nitrate, you can see A over here clear. Okay, and the formula is also NO3, not NO2. Ammonium nitrate decomposes when heated in a very similar way, to ammonium nitrite. Suggest the formula for two products made in this reaction. I'm writing here, ammonium NH4NO3 is decomposed to form water and nitrogen, N2 and water 2H2O, 2H2 and O, and one oxygen is left. I'm writing here. Okay, so N2O nitrogen, because one oxygen is extra, so that's why it will be added with the nitrogen and then water. Okay, this is the answer. Simply you can write this equation instead of writing. So these are two products. Okay, describe how a pure sample of aqueous ammonium nitrate can be prepared from the dilute nitric acid. Okay, whenever we have to prepare a pure sample, okay, then we can get the help of titration. Aqueous ammonium nitrate. Observe and think about its formula. Ammonia means NH4, nitrate means NO3. So NO3 will come from the nitric acid, and ammonium will come from the ammonia. Ammonia is a base. Ammonia is base, and nitric acid is a. I mean that nitric acid is acid. Okay, you know that. So describe how prepared from the dilute nitric acid. Okay, take base in the burette and acid with measured volume and concentration in the conical flask. Allow the burette, allow the base to run through the burette into conical flask until end point is observed by the color change. By using indicator. Okay. Okay. At that time you have to stop it. Okay. So that will be the, you'll see that will be the pure ammonium. Means you can say ammonia is coming from the burette. Okay, NH3. Okay, and HNO3 is present in the conical flask, so NH4NO3 will be formed. Okay, as a result. Okay, so we have over here molybdenum from the transition elements. Okay, it is extremely hard. It is used to make the steel that is extremely hard. Molybdenum can be manufactured by heating together molybdenum oxide. Okay, so like this, and aluminium. Okay, so construct equation for this reaction. Molybdenum can be manufactured by heating molybdenum oxide and aluminium. So we can take aluminium over here, aluminium, it is in the solid form, it is allowed to react with the molybdenum oxide, MoO3. Okay, its oxidation state is 6 plus 6. Okay, so you will see we'll get molybdenum and Al2O3. This is also solid, this is also solid. Okay, explain this reaction involves the both oxidation and reduction. Yes, aluminum is oxidized because it gains oxygen, and molybdenum is reduced because it loses oxygen. So aluminum is oxidized due to gain of oxygen, while molybdenum is reduced due to loss of oxygen. What is the mass of molybdenum can be made from the 125 gram of the molybdenum oxide? Okay, what is mass of molybdenum oxide? MoO3. So 96 plus 3 multiply 16, it becomes 48 plus 96, it becomes 144. Okay, for molybdenum oxide. So let me write over here, sorry, 125 gram of molybdenum oxide if we have. Let me find out number of moles. Okay, so number of moles is equal to 125, this is given mass, divided by 144. Okay, so 125 divided by 144, 0.868. So number of moles of molybdenum, so molybdenum oxide ratio molybdenum. Okay, 1 mole of this will form 1 mole of molybdenum, and 0.868 mole of this will form same moles. Okay, 0.868 multiply by, what's the mass of molybdenum? 96. 83. 83.33 gram is given over here. Okay, which metal is less reactive, aluminum or molybdenum? Molybdenum is less reactive, that's why, because aluminum can displace it, is less reactive because it can be displaced by aluminum. A heavier metal can displace the more reactive metal can displace the less reactive metals. Okay. Molybdenum has a melting point. This one. Describe metallic bonding with the aid of the labeled diagram. In this way, you will make the diagram. You will show the cations. Okay. Metallic cations closely packed to each other. Third layer is going to be okay. I'm not going to draw. My drawing is not too good. So plus charge will be there on this plus 6 charges. Okay, because they lose 6 electrons, so its excitation state is molybdenum is you know that V1. Okay, so plus 6 charge. So when each is losing many electrons, 6 electrons. Okay, so those electrons will be there moving freely in the intercationic spaces. Okay, so describe a metallic bond with the aid of. Okay, so metallic bond, a label diagram. This is the metallic cation, and this is the mobile electrons or delocalized electrons. Okay, and the electrostatic force of attraction between metallic cation and free electrons is called metallic bond. Okay, so this is why molybdenum has a much higher melting point than aluminum, because it has a stronger metallic bond. Okay, molybdenum has a stronger metallic bond due to release of 6 electrons by one atom. While one atom of aluminium loses 3 electrons only, hence melting point of molybdenum is higher than melting point of aluminium. I think this is the last question. I hope so. Large quantities of polychloroethene are manufactured annually. Okay, the flow chart shows the steps involved in the manufacture. Crude oil we have the petroleum, and from here we get ethene, and salt solution we get the chlorine from here. Okay, and the chlorine and ethene, those both react to form the dichloroethane. C2HO2 more than double. Okay, 4, and instead of 2 hydrogen I'm writing 2 chlorine over here, dichloroethane. Then it becomes chloroethene. Okay, chloroethene, only one hydrogen, one chlorine is removed, C2H3 and Cl. Okay, one chloro, only there is one chloro. Okay, one chloro. And polychloroethene, name the two processes used to manufacture the ethene from the crude oil. One is a fractional distillation. Okay, as alkanes are separated on the basis of their boiling points, in the same way this alkene ethene is also separated. And the second is cracking. Longer molecules with the high boiling points are broken down into the smaller ones, and from here we also get the unsaturated alkenes like ethene. The salt solution is electrolyzed using the carbon anode. Write the equation for the reaction occurring at anode. Salt solution, definitely it contains chloride ions, that's how you get the chlorine. Okay, so at anode it has a plus charge, So two chloride ions will move towards the anode to form the chlorine gas, and two electrons will be given off. Draw the structure showing all the atoms and bonds of the dichloroethane. Ethane is one carbon, two carbon. This is ethane. Etha means two carbon, and ane means single bond. Okay, dichloro, one chlorine over here and one chlorine over here. What about the remaining valencies? Remaining valencies are satisfied with the hydrogen. When dichloroethane is heated strongly, chloroethene is formed. Name the other product of this reaction. Chloroethene. Let me tell you. Uh, I'm writing here C2H4Cl2 when it is heated. So C2H3Cl is formed. What is left? So one hydrogen is lesser. Okay, because here is 4 and here is 3. There is 2 chlorine and here is 1 chlorine, so HCl. So other product is HCl. Okay, current to law of conservation of mass, left and the right sides, both reactants and products have to be equal. Okay, so other product is HCl. Okay, the structure of chloroethane, you can see here chloroethane. Draw the part of structure of polychloroethane. Simply it will be like this: hydrogen, 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 and this is the chlorine. Double bond will convert into the single bond. Okay, a factory uses the 20 to 50 tons of the chloroethane to make the polychloroethane, reduce the maximum mass of the polychloroethane the factory could make. As much we take the chloroethane, will convert into polychloroethane without loss of anything, because here is the additional polymerization. Double bond is converted into a single bond, so same mass will convert into the polychloroethane. Okay, so 20 to 50 tons. Okay, what's over here? Actual yield of the polychloroethane is 21 20 2175 tons. Calculate the percentage yield, and you know that percentage yield is equal to actual yield over theoretical yield. Actual yield is 2175 and theoretical yield is 2250 multiplied by 100. Okay, so here we go, 2175 divided by 2250 multiplied by 100, 96.66. Okay, alkanes are homologous series of the saturated hydrocarbons. The table shows the information about the some alkanes. We can see over here, lubricants is liquid at 25 centigrade. Okay, so how can we make the deduction from that idea? When something is liquid, it means our room temperature is 25 centigrade, so its melting point is lower than and the boiling point is higher than, so that's why at room temperature it exists as the liquid. Its melting point is below room temperature, while boiling point is above room temperature, so it exists as liquid. Butane melts at minus 138. Use kinetic particle theory to explain what happens when the butane melts. Temperature is absorbed. Okay, this is very simple. Temperature is absorbed. Kinetic energy of molecules increases. Which overcomes intermolecular forces, and molecules start moving freely. Like liquid. like a liquid. Okay. A sample of ethane gas 0 centigrade and at pressure 1 atm. Okay, atmospheric pressure. The pressure is increased but the temperature is maintained 0 centigrade. Describe and explain in terms of kinetic particle theory what happens to the volume of the gas. Pressure is increased and temperature is maintained 0 centigrade. Okay, so pressure is increased. On increasing pressure, what will happen? The volume of of ethane will decrease due to closed and increasing pressure. Okay, closed movement of gas molecules on compressing. Okay, suggest the method of separating the mixture of hexadecane, dodecane, and explain your answer. So fractional distillation. Okay, fractional distillation. And you know what is fractional distillation? Separation of mixture of liquids on the basis of their different boiling points. On the basis of their different boiling points. Draw the structure showing all the atoms and all the bonds for two isomers with the molecular formula C4 and H10. Means it is the alkane. 2 more than double. Okay, double is 8 and 2 more than double is 10. Okay, so C4 and H10. This one 1 2 3 and 4. Now their valences are satisfied with the hydrogen. 1 bond is here, 3 bond with hydrogen, 2 bonds with oxygen with hydrogen, 2 bond with hydrogen, and 3 bond with hydrogen. Okay, 4 valences of the carbon have to be satisfied in organic chemistry. Make it clear. And in case of this is the methyl propane. Okay, hydrogen, hydrogen, hydrogen. All the valences of carbon are satisfied with hydrogen. So formula is same, C4H10. The structure of hexane is 1 2 3 4 5 6 carbon carbon single bond hexane. Okay, draw the structure showing all the atoms and all the bonds of the organic product of the reaction of the hexane with the chlorine. When hexane is from alkane, it takes with the chlorine, so substitution reaction will take place. So what will happen? One hydrogen and then second hydrogen will be substituted with the chlorine. So I'm writing the same structure, and here one is substituted with the chlorine and rest of the bonds are with the hydrogen as it is. And when we proceed it further, then second will also be substituted with the chlorine. Okay,